All right, what's the SI unit for mass?
Kilogram.
Kilogram. Now, the stuff that's in 1 through 3, if I ask you any of those kinds of things on the quiz tomorrow, a lot of people don't study for those kinds of things. And then when I ask that, they get pelted with that on the quiz, and they're like, I know you're going to ask those things, Miss Wall. All right, we didn't spend a lot of time on that. We're not going to spend a lot of time on that today because anybody can look through their notes and study that tonight, right? We're going to spend more time on the math portion of the quiz because those are the things people need more practice with.
Yeah. Right.
Okay? So don't forget to look over those things before tomorrow.
Did we go over what equipment?
No, but
Okay.
what are you going to measure temperature with? Thermometer. What would you measure length with? Ruler or a meter stick would be fine. I'd take either answer. What would you find volume with? Graduated cylinder. All right. For those of you who don't remember what they look like, they're right here.
Is there multiple choice or open-ended?
Open-ended. Most quizzes are open-ended. Very, very, very few will be multiple choice. 10. Sometimes less. Depends on the type of question. If they're, as we go through the semester, the questions get harder and longer to work. The quizzes get shorter.
So tomorrow will be 10.
Tomorrow will be, I think it's 10. I haven't run it off yet. I have batches of things I can pick from, so it depends. But I'm pretty sure tomorrow will be 10. Yes, ma'am.
So which ones do we like?
Such as?
Like
Yes, the ones we just went on. Triple mean balance thermometer, graduated cylinder, those types of things. I'm not going to ask something obscure that you would not know. Okay? Yes.
So will the majority of them be the math?
The vast majority will be math. Okay, less than 20 points will come from what is in 1 through 3 up there. All right, so number 4. This is like your homework last night, so these should be something we should be pretty good at, I hope. 125 grams to kilograms. What goes on the top line? All right, 125 grams. What goes on the bottom? On the top? Who's bigger? So you put a 1, and how many spaces between killi and gram?
3.
King Henry died by drinking chocolate milk. Anybody have a question on how they said 3 spaces?
No.
Are we good?
Yeah.
So 1, 2, 3, in case somebody's shy out there and doesn't want to ask. Okay? So do we multiply or divide to get the answer?
Divide.
We divide. If you still want to, you can multiply by 1 and divide by 1,000. But essentially, you're dividing. So 0.125 kilograms. Questions about number 4. All right. Number 5, we have 35.6 decimeters on the top line. What goes on the bottom?
Decimeters.
What goes on the top?
Meters.
Who's on the bottom? Or which? Let me ask this. Who's bigger?
Decimeters.
Changing the way I'm asking the questions. So, how many spaces between? How many spaces between deci and milli? So 2 zeros and a 1. How do we calculate this time? So 3,560 millimeters. Any questions about the opening? Now, if I were you, I'd just draw a line under it so that tomorrow you can do opening number 2 on the same sheet of paper. I know I always get 1 or 2 people who use 10 sheets of paper. It's incredibly wasteful. Okay? Some of you will be ingenious and get all 10 openings on the same sheet of paper. That's fine. Typically, it takes about 2 sheets of paper to do all 10 openings. Okay? Any questions? All right, let's talk homework. I would like to see it very quickly because I know, I feel it. Everyone's going to have their homework today, and I'm going to have 2600s unless they didn't do it. Since you came by and got it yesterday. And that way, everybody starts out with a fabulous grade.
Grading on accuracy.
No, grade on participation. I never grade on accuracy.
Okay, yeah.
If I grade on accuracy, it's going to take me forever to grade this. And some of y'all are going to get 100. Let's make this quick. We're already behind. Like I said, so you can start away. She's got hers too. what I like about people joining the class. Know how to catch up. Now, you guys with all this stuff in the aisles, y'all are gonna have to be mindful of pour on this wall. Yes, up there behind my desk. You know, I'm not the most graceful person. I managed to fall on the sidewalk last summer and break my wrist and spend 4 months in physical therapy. So be careful with all that extra stuff y'all have in the aisles and try not to trip me. And if I do fall, help me up. Just go back there and blow your nose. All right, so if we look at the answers to your homework. Question number 1 should be 0.0156 meters. Decimal 0.156 meters. Number 2, 1.25 hectometers. Number 3, decimal 35 decameters. Number 4, 650 hectometers. Number 5, 16840 millimeters, or 16,840 millimeters if you prefer. And the last one, number 6, decimal 0.00156 kilometers. Any questions you need me to work? Yes, my dear.
Can you repeat that before?
Sure. 650 hectometers. Anybody need me to work any of 1 through 6? So if that was the quiz today, I'd have graded all hundreds.
You should do that.
We should do that. Okay. I said I did a good job yesterday. All right. So yesterday when we were converting, we did not. Huh?
I had to rewatch the last one.
Well, aren't you glad that I recorded
Yeah, I'm really
it?
glad you did that. It's gonna help me a lot this year. My mom's just gonna hear this wall coming from my room all the time.
In that case, you might have nightmares.
Can I give myself one?
Yes, you can. Just write a 100. Now, yesterday, we did not get to cubed units, okay? We would have done that had we had a little more time, and then we would have gone to volume conversions. So, yesterday, when we were doing the factor label method, we didn't get to cubed units. Now, those of you who move decimals, this will not work with decimals, just moving them left or right, okay? So, suppose that you have 4.58 meters cubed, and you want to change this to centimeters cubed. Now, the only thing that is different about this conversion and the one that y'all made for your homework is both units are what? Cubed. So the process is the same except for one tiny little step that we're going to add in, okay? So you still do the exact same thing that you did last night. Still draw your chart. You do all the same steps, and we're going to add one final step in. So 4.58 meters cubed still goes on the top line. What goes on the bottom line? Meters cubed. What goes on the top line? Okay? You still ask yourself, who's bigger? Who's bigger? Okay. King Henry died by drinking chocolate milk. And I like to use this one as my example because this one is a common mistake. People look at this one, and what do you think they think this stands for right here?
Meters.
It is meters, but what do you think they look at it and think it is sometimes?
Millimeters.
They think it's milli, okay? This is meter, but sometimes when they go to count and they go to look to see who's bigger over here, it's real easy to look up there and go milli, centi, and go bigger, smaller, and don't write this, and write that's bigger, and go one space and write a 10.
Yeah.
I get that all the time, okay? So don't fall down that rabbit hole or that trick, okay?
But millimeters would be the 2 M's.
That's right. Millimeters would be the 2 M's. And make sure you remember that because it's easy for students to fall for that and go, oops, and make that same thing I just wrote on the board up there. It only has 1 M, so it's on the baseline. So meter is there. Okay, everybody good with that? So Yes, ma'am.
You call these the converting what to what? Because I was trying to type those notes.
Cubed units. These are just cubed. That's the only thing that's different. It's still converting. It's still a factor label method. The only thing that makes this different is these are cubed. Okay, they're both cubed. Yesterday's homework had nothing that was cubed. You see how these have these little 3s on them right here, just like in math class? That's what makes these different. Okay? So, who's bigger, a meter or a centimeter? So you're still going to put the 1 with a meter, and you're still going to count your spaces just like you did last night. So how many spaces between meter and centi? So you're going to put your 2 zeros and your 1. Now, here's the new step. If both units are cubed, cube the numbers. Okay? If both units are cubed, cube the numbers. So, we're going to cube this 100 and this 1. Okay? Now we just have to punch it in the calculator. You remember how to do that in your calculator? Is that up caret 3. That's it. So 4.58 times 100 up caret 3. And I don't know if it'll put it in scientific notation or if it'll multiply it out. Sometimes it'll do it, sometimes it won't. Yep, it'll do it. Whoops, I need to do that. Everybody there? Is that what you got? Yeah? It's 4 zeros. Okay. Everybody see how to do that? Yes? Because we're going to talk about something that's different here in just a second. All right, so let's say we have 7.58 hectometers cubed, and we want to change it to, I don't know, decameters cubed. Can we do it? Yes? No?
Yeah.
Yeah, works the same way. Okay, all you notice is both of them are cubed, right? So draw your chart. Who goes on top? Okay, 7.58 hectometers cubed. Who goes on the bottom? Hectometers cubed. On top? Decameters cubed. Who's bigger? Hectometers. How many spaces between a hecto and a deca? So that's 1 0. Now, because both of these are cubed right here, what do we do? Cube them. And then calculate. So 7.58 times 10 raised to the third should be 1,000. So 758, 0, and then decameters cubed. Yes? You with me or no? Okay. Now, how is this different from something else we're going to do? All right. Everybody good? All right. Now let's talk derived units. All right. There are 3 derived units we're going to talk about today. We're going to do area. We're going to do volume. And we're going to do density. Density will be at the very end of class, but hopefully you remember that from another science class. It's not new to me. All right. Area. Tell me what you remember about area from probably late elementary school. It's what? Y'all know the formula. There you go. Area equals length times width. Okay, so what's the SI unit for length? Hence the need to brush up for the quiz tomorrow. All right, meters. All right, what's the SI unit for width? What? Yeah. Okay, now, your math class. What do you get when you say a meter times a meter?
Meter squared.
Okay, meter squared. All right, so meter squared is the SI unit for area. Okay, so anytime you see a square, that tells you it's an area. But meter squared is huge. Okay, so we'd have a meter stick this way and a meter stick that way to measure area. That's huge. All right, so we don't use meter squared very often to measure an area. So, can you give me something that's a common unit that might be smaller for area? Yeah, centimeters what? Squared. Can you give me another one? Yeah, millimeters squared. Okay? Meter squared is just gigantic, so we don't use it a whole lot. But centimeter squared is much more common, and then millimeter squared is a little less. All right, so if we do the same thing for volume, all right, what's the formula for volume? There we go. All right, length times width times height. And using the same process to find the SI unit, what is the SI unit for length? What's the SI unit for width?
Meter.
What's for height? So what do you get when you multiply?
Cube.
There you go. All right, so when you see something that's cubed, you know it's a volume. All right, now, again, meters cubed is gigantic. Okay, so picture it. I had to go get some paper for Miss Thornhill today because she was having a hissy fit that she hadn't had her paper. And it was down there in the annex hallway. You know, and I have a bulging disc in my spine, so I make it a point never to lift 50 pounds of paper. So I got some children to go with me to lift her paper today. So picture this. You got a meter this way, a meter this way, and a meter that way. And that's how you had to buy your soft drinks at Walmart. How many of y'all going to buy a soft drink? If you had to buy a meter cubed,
Tier 1.
cheer one. Taking a forklift? I've not lived it. I mean, back before I went on my diet and started losing weight because my doctor had a stroke about my blood pressure. Because, you know, they want to put me on 2 blood pressure pills. I was like, look, I'm not taking 2 blood pressure pills for teenagers. I'll just lose a little weight because I can manage this. I mainlined Pepsi for a long time. I think I was drinking it intravenously. I would have needed a forklift to bring this stuff home if I had to carry it in a meter cubed. So that's a little unmanageable. I don't think most of us could carry this. Even Ms. Bowers might struggle with a meter cubed of Pepsi. If I told her, Ms. Bowers, come with me to Walmart. I need you to lift this for me. That's how I got my paper, by the way. I just figured go down there with me and put it on the cart. All right. So how is it that we would carry it? It'd be a little tough. So meters cubed is the SI unit. We can't carry that. So give me a unit that's much more common.
Millimeter centimeter.
Okay? So is it going to be cubed? Okay, so centimeters cubed or millimeters cubed. Now, can you give me some units? This is the thing about volume. They have some other units that we use all the time that are not cubed. Can you think of what they are? Think about 2 liters that y'all buy.
Liters.
Liters. And what's the smaller one if y'all buy the little bottles? Yeah, milliliters. Y'all use liters and milliliters. If you buy water, you can buy a liter bottle of water and a milliliter bottle of water too. Okay, yeah, I've switched to water too. Although I do like what's that stuff called? It's the Orangeade. It's by yeah, that's it. Because that's sugar free. Although it does have aspartame, so I try not to get crazy. But I don't like tea or any of that other stuff, so it's the only kind of flavor I get now other than plain water. All right, so we'll come back and talk about volume conversions in just a second. Tell me what you remember about density, because we're going to do its formula while we're talking.
Nothing.
Not a thing. I don't remember anything about density. From middle school, elementary school might have been a little early for density. Some of you might have done it in 5th grade, but most likely you did it in middle school. I got a lot of shaking heads back there. Not that it was
No. We were too focused on
you were too focused on puberty. All right. Maybe that's wrong with my son. All right. Mass divided by volume. Okay. Density equals mass divided by volume. Does that formula ring a bell? No. All right. It's defined as mass per unit of volume. Do we remember anything about what that means? Like why ice floats, for example.
solid.
Okay, one's less dense than the other. Okay, we're making a little headway. Okay. Yeah, okay. All right, we'll write that down in a second. I'll let you catch up. Because I'm going to need to change the screen or it's going to be so small Nada's going to need binoculars. Huh?
Nadia.
Nadia. Can you see from back there? Yeah, you're okay? Okay, because, you know, I know it's not great to sit on a stool, but if you ever get to the point you can't see from back there, you can sit up closer. Okay? All right, so if we have, let's just say that I pour 3 liquids in a graduated cylinder, all right? I pour some, all right, some Cheerwine. Some oil, no, Cheerwine's like water, and some molasses in the graduated cylinder, okay? Now, they're going to separate themselves based on density, right? Okay, you should have talked about this in middle school. What's going to happen? Who goes to the bottom? Okay, why will the molasses go to the bottom? That's right. It's the most dense. It has nothing to do with the thickness, even though a lot of people think that. The one that is most dense always sinks and goes to the bottom. So since you often know when you get something to drink and the ice floats, what do you know about the ice? It's what? It's less dense. So which of these other two are going to be less dense? The oil. Okay? Oil is less dense. Now, that's why when you took driver's ed, what did they tell you about rain and when it was most dangerous to drive? When it first starts, because the rain causes the oils to do what? To come to the surface, and that makes the roadway a little more slippery, and it's much easier to break traction with the road. Okay? The Cheerwine is going to sit in the middle. Okay? The oil then will be less dense. Okay? So anything that's less dense will rise. Anything that's more dense will sink. Now, while we're talking about units, okay? If density is M over V, all right? What was the SI unit that we learned for mass? Kilograms. So that means we would have kilograms. All right. What is the SI unit that we just wrote down for volume? meters cubed. That's good. Okay. This is the SI unit. Okay, it's mammoth. We don't generally calculate densities in those. We can. They're going to be very big numbers. We generally don't, though. Okay, we tend to use common units. So, give me a common unit that is smaller than kilograms and meters cubed. Gram. Now put it over a smaller volume unit. Centimeters cubed. Okay, give me another one. All right, grams over, don't say milliliters cubed. That was just milliliters. We don't cube the milliliters. I'm going to talk about that in just a second. Okay, but those are common units, and those are the two you'll see most often. Okay? Questions about that? Now, we're going to spend the vast majority of the rest of our time today working math problems and talking about how to do volume, scientific notation, and converting.
Sounds so much fun.
I knew you'd love it.
So excited for it.
Yeah, your sister told me ahead of time that you would not like chemistry.
Yeah.
Okay. That's good to know she didn't lie. All right, so let's talk about volume for a minute. Now, the hardest part about volume, and the thing that will drive you nuts, is the converting with volume. Because you have to learn this relationship. 1 centimeter cubed is equal to 1 milliliter. These two units are one and the same. They can be used interchangeably. Okay? So, they often drive people crazy because I will say things like, convert 15.34 centimeters cubed to milliliters. Correct. It's the same thing. Okay? Now, a lot of people look at that and they go, just like several people in here did, isn't it just 15.34, Miss Wall? And the answer is yes. These two things are what? The same thing. So you can just write 15.34 milliliters. Now, if you don't realize that, some people do this. Actually, a lot of people do this.
Work it out.
They do this. I don't care if you write it down, but I'm going to work it wrong. So if you write it down, realize I'm working it wrong. They do this, and then what do you think they do? They ask themselves, who's what?
Bigger.
Who's bigger?
I would be tripping so hard on this. I'm like,
They look at it, and they don't really notice the milliliter and centimeter cube part is equal. They see milli and centi, and they go, oh, centi's bigger. And then how many spaces are between milli and centi? And then they put a 10 here. Okay? Which is wrong. You have to remember that these two things are equal. So if you're going to draw a chart and they're equal, what do you put here? You put ones because they're the same. Okay? And then it's just 15.34 milliliters. Most people don't draw a chart there. Okay? Because they're one and the same. Now, what if I say, I don't know, 42.84 liters, and I want you to change it to centimeters cubed? What if I want you to do this? What would you do there?
Switch out centimeters cubed for milliliters.
Yes, exactly. That would be the easiest way to do it. Okay? So when you look at this, the easiest thing to do is to remember centimeters cubed is the same as a what? It's the same as a milliliter. Now you've got liters and you're going to what? Milliliters. And it's the same chart that you've been drawing. Okay? So you're not having to go from liters to some weird unit. You're just going from liters to what? Milliliters. Because you've gotten rid of that cubed unit that doesn't match what you started with. So you're going from 42.84 liters into milliliters. Now who's bigger? How many spaces between a liter and a milliliter? King Henry died by drinking chocolate milk. Where's the liter sit? So how many spaces between the baseline and milli?
30.
So then you can do your 3 zeros and you've got it. Okay? So 42.840 milliliters. Questions?
Let's keep doing one.
Okay? Now, I want to learn how to do scientific notation, and then we're going to practice. And I can roam around and help with the conversions and the scientific notation. But I don't want to have to write 8 zillion zeros with the practice.
So basically, this is only going to help us in life if we work at a bottling company.
I'm not going to help you at all. Unless you do something with a science field. Told you. Most of this is a hoop. I can admit that openly. All right. Now, scientific notation. Now, how I kept calling out answers and going 0, 0, 0, it's going to get worse as we cruise through the semester. A lot of your answers have to be written in scientific notation because one of the numbers we're going to use has an exponent of times 10 to the 23rd. I'm not calling out answers with 5, 6, 27 zeros. So we have to learn how to use scientific notation. It's actually part of the Math 1 curriculum, and you should be able to use it. However, a lot of people don't know how to use scientific notation when they come to me. So we're going to have a short mini lesson, and then we're going to learn how to do it on the calculator. Okay? So scientific notation is essentially something that's like 6.57 times 10 to the 4th. Okay? This number has to be between 1 and 9. Then you have a decimal. The exponent can be positive or negative. It doesn't matter. Now, you might remember if you have a number like 4,125, the decimal is where? At the end. So if we have to have a number between 1 and 9, where does the decimal need to move to? After the 4. So the decimal that's here is going to move 1, 2, 3 spaces so that we end up with 4.125. That's why it goes to behind the 4, because you need a number between 1 and 9. Now, how many places did we move the decimal? That's how you get the exponent of 3. Now, if you move the decimal left, okay, if you move the decimal left, it's a positive exponent. So that's why it's positive 3. And I just wrote positive 3 to emphasize you do not have to write plus 3. Okay? Now, if you have a number such as 0.002, let me say this, just so we have some contrast here. 381. Okay? Again, you want a number between 1 and 9. So, my decimal must move to behind which number?
3.
Right. So, 1, 2, 3, 4. So I'm going to have 3.81 times 10 to the, how many places did I move it this time?
4.
So I'm going to have an exponent of 4. Okay? This time, I move the decimal. Color here. Color. All right. I move the decimal to the right. So I have a positive x. All right, stupid. I have a negative exponent. I'm the only person allowed to call anybody stupid in here, and I call myself stupid. Y'all can't call anybody stupid, and you can't call me stupid. Only I can. And I can call myself stupid. And that's it. Just me. All right, so I moved it to the right, so I have a negative exponent. That's essentially how it works. Now, we're going to let the calculator do the work. Does anybody remember doing that in middle school? You should have. Most of y'all were probably in Math 1 in middle school.
Yeah,
Yeah.
but Harrison killed me mentally.
I love Harry.
Okay.
He's so funny.
Okay. I'm glad he was funny.
Yeah, you got
You remember doing it.
it.
Okay.
He was roasting kids.
Right, that's why he was funny.
All right. Now we're going to talk about how to calculate on the calculator and multiply numbers together. All right. Now, suppose we have a number like 4.81 times 10 to the 8th, and we're going to multiply it by 7.49 times 10 to the 5th, and we want to get an answer. Now, the calculator is doing the work. You just have to learn how to put it in the calculator.
I think I know how to.
Okay. Now, we do not hit times. We do not hit 10 on that calculator. Okay? These are scientific calculators. This times 10 is programmed with a key that is E. Okay? Okay? So on your calculator, you're going to type in 4.81. You do not need the parentheses. They're just times. All right? You need to find the EE. For most of you, it's going to be a second function and on top of the comma. Unless you have one of the really old calculators, and then it might just be a straight up EE key.
Or it
Yes.
might just be a black key.
What's wrong with it? Oh, yeah. Bert, come here. I'll give you batteries. You're capable of changing batteries, aren't you?
Yeah.
What's your name?
Kevin.
They only give me one.
I ain't call attendance today, so I didn't get to learn any names and faces here.
Does it only give me one E? Yeah. Okay.
Just throw those four in the trash. All right, so you're going to say 4.81 and then second EE. Now, when you push second EE, I want you to tell me what happens on the calculator. You should see a little E come up on the calculator.
Yeah.
Now, that means times 10. The calculator is programmed with times 10. It's asking you for the exponent. It's saying, what is the exponent? So you put 8.
Not the up arrow?
Not the up arrow, just 8. Okay? Then you say times, because these parentheses mean what? Times. 7.49. Again, it says times 10, so you say second. And EE. You should see another what pop up on the calculator? A little E, because it's asking you again for the what? It's asking for the exponent.
Oh, yeah, got it.
And you say 5, and you get an answer.
Big decimal.
Now, when you get an answer, you have an E in the end of it. Okay. Now, we're going to talk about how to round this in a couple days. We're just not there yet. So, round off to like 2 numbers behind the decimal until I teach you how to round, which we will get to. Okay? Now, you see that E at the end? It's telling you the exponent. We don't write E14. That's wrong. Okay? It's telling you the exponent, so you have to translate that back into scientific notation, right? So you're going to write times 10 to the what? To the 14th. Okay? Is it ringing a bell? I got it. I don't want you to have any bad flashbacks here.
Like, my thing just mentioned when they killed me, like, when I'm crying. All the time.
All right. All right, let's try some more of these before we practice with charts. I'm just going to bring some up that are typed already instead of me making crap up. So it's neat.
It's harder than pre-cal. No.
This is not harder than pre-cal.
This is easier than pre-cal. Pre-cal.
What have y'all been doing?
Math first. We've only been going over math first.
This is what, my second day in pre-cal?
Doing that. Okay, so the.
Okay, well, you've got it. We don't.
It's really too really easy.
All right, we're going to try calculating those four. Okay? All on the calculator. Now, before I even let you loose, what does that mean? Just checking. Okay? You can't get the right answer if you don't know what it's asking. Now, if you get it and it doesn't come up in scientific notation, do you know how to change your calculator? You know how to go to mode?
Yeah.
You know how to hit science?
Okay.
Go to sci
Yeah.
and enter, and then clear it. All right, then. How'd y'all get out of math class? Y'all are like recap and don't know how to go in. Oh, just clear it pretty much. Okay, sure how all that was. Are you in scientific mode? You can. And sometimes if you don't mess anything up, you can just hit enter and it'll change your answer in scientific. What the heck was? See how you did exponent 10? Get rid of that. Okay, 7.51. Second EE, and then just tell it. Okay, no 10. All right, who else? Anybody else not have the calculator scientific?
You don't have to retype it again.
I know, exactly.
I'll like it off.
Who else? All right, y'all are your number calculator. Oh, it's right here. What's wrong?
Maybe
Maybe the one that's auto contract. Yes. Well,
Hey.
So just right.
Yeah, they're pretty expensive.
They got an Amazon for this?
Yeah.
Where?
I don't have storage.
Question?
Well, delete.
Where can we find scientific calculators not for $80?
Great.
Try Amazon or eBay. See if
They'll be
you get
used,
one that's, used or reduced. Most of mine have a lot of age on them, so try not to drop them on the floor repeatedly.
Sorry.
If this is on the quiz tomorrow, I feel good.
This is not on tomorrow's quiz. It is on a quiz, it's just not on tomorrow's.
Well, now we're.
This will be on a future quiz with significant digits. Yes, dear. You can, because you cannot use your phone calculator. Even though it is super cool, you gotta use a phone. And if you have your own calculator and want to use it, you can. You just can't use your phone.
That every student should get.
Will I ever what? Would I ever give you homework where you need to do something like this? Yes, and there you can use your phone if you have a phone, which is why I said you might want to get a scientific calculator. Now, you do not have to have a graphing calculator to do this. You can get a $15 scientific calculator at Walmart.
Where?
And if you can't figure out how to do it with that, bring it to class and I'll show you how to use it. I will tell you that I find Texas Instruments to be the easiest to use. Casio and Sharp can be a little harder, but as long as you bring the instruction manual, I can probably figure it out. Okay? But you do not need a graphing calculator for this class.
She said it's best.
Now, I mean, if you're going to be someone who takes advanced math classes, you have any interest in AP Calc or stats, and you're going to stay in advanced math, truthfully, I'd invest. But if you just cannot afford it, you do not need it for my class. If you're good with apps, or what type of phone did you have? An Android phone has a fabulous math app, a calculator app that Apple, I'm an Apple fan to the T, but their calculator apps just are not as good as Droid's. They're just not. And I don't know why. They really need to step up their game because the Droid phone apps are just much better for calculators. And I don't know what their deal is. They need to fix that.
Don't you? Yeah. Well, won't you need it for the SAT and ACT?
You can use your own calculator for that, yes.
Because my friend, she came into the SAT and she didn't know that you had to bring your own, so she didn't have a calculator for her last SAT.
Yes, you have to bring your own. Now, sometimes, if you take it here, sometimes they'll loan you a calculator. But if you take it at another school, then you've got to take your own calculator. All right. So the first one, what'd you get? Somewhere in the 4.78 range times 10 to the 7th. Some of you probably rounded up, and that's okay. I told you we learn how to round, but you're in the 4.7 range times 10 to the 7th. All right, number 2.
7.92 times 10 to the negative 17.
Clearly, I punched that in wrong. Is everybody on the times 10 to the negative 17?
Yes.
Okay, I just punched it in wrong. All All right, number 3. 2.1 times 10 to the 5th?
Yes.
Okay, we're all on the same page there. And the last one.
1.32 times 10 to the 11.
All right, 1.32 times 10 to the 11. All right, so we're okay with using the calculator and operating scientific notation. All right, let's talk density, and then we're going to spend the latter part of class practicing again with math and using the 2 notations. All right, and get rid of that. Let's talk density for a minute. Density. That's, I don't think what I want, but there, that's what I want right there. All right, I need to hand out a chart. Now, these orange tables that I'm giving you, put your name on. You cannot write anything on them unless I say you can write something on them other than your name, because they're identical replicas of what you will be given on the state test. You may use these on every test and every quiz that we take. That's the reason you cannot write anything on them unless I say you may write something on them. Because if you write notes on them, you will have to use my copy, not yours. They're on nice bright orange paper because I do not want you to lose them, and I want you to be able to find them in your notebook. Okay? Everybody got it? Now, Now, density problems can run the gamut from the nice and easy to the hard. Now, if we start with the blue one, and I don't know if you want to write it down or not, I don't care. I have no dog in this fight. If you want to write the blue question down, I will be patient and wait. Okay? The only reason I would do the blue question is to illustrate the units on the answer. Okay? Do you need me to give you time to write the blue question? Okay, can I be patient?
Is this still practice?
It is. This is all part of your notes. Our school's feeling better now. Let me take the attendance.
You should call it our names.
I should. That's a good idea. I need to start working on faces with names here. All right. Where's Natalia at? That's Natalia. I know him well. Alejandro. That's Alejandro. Tell. Cecilia. Got Herman. Destiny. Kaya. Cameron. Allie. Kayla. Alejandra. Alondra. Kevin. Y'all related? No.
Yeah, we are.
Yeah, grade levels.
We are.
Madison. Noah. Alright. Chris. Patrice. Karen. Joyce. Rosanna. Karen. No, let me get straight. Faith, I know. John is not with us anymore. I marked that one out. Because I don't know why he was in here. I've already told him. Linda, I know. All right, Cynthia is which one? Patricia, the other one then. And Nadia, I know. Yeah, my work cut out for me here. All right, so if we look at the first one, all right, find the density. This is as easy as it gets, and the only reason that I wanted to talk about this one was just in how to write the unit. So finding density, the formula is mass over volume, right? You're solving for D. The mass is what? 12.5 grams, and the volume is 3.89 milliliters. Now, solving would only require us to do what? Just divide, okay? We don't have to convert anything. You're just going to divide here. Now, the reason that I want to talk about it is the units. And a lot of people think you have to convert because the units don't do what? They don't match. So, when you divide this,
3.21.
thank you. What you do to write your answer down, because the units are different, is you just write grams over milliliters. The units are different, and because this particular problem is a density problem and it's a mass per volume answer, your unit will be a mass per volume unit. So you keep both units in your answer. Now, if we look at number 2, or the orange problem, to contrast the question. All right, it's asking you to find a volume, okay? So if you're looking for a volume, and I'll give you a minute to write the question down in a second. Look at the 2 units here. What can you tell me about the units? Do they have anything in common?
They have match.
They halfway match. So when we solve, what's going to happen to the 2 masses? They're going to cancel out. So the grams are going to cancel out, and you're going to be left with what? Milliliters. And you're solving for a volume, and milliliters is what kind of unit? What kind of unit is a milliliter? Where did we stick it earlier in our notes today? Did we put milliliter on a density unit, a volume unit, or a mass unit? It was a volume unit. So that's why we're going to be left over with milliliters, because milliliter is a volume unit. And I'll give you a minute to write that, and we'll do this one. Because sometimes people mess up the math on this one. So we'll walk through it. I don't think many of you will, but just in case somebody does, we'll walk through it and make sure everybody's okay. All right, so if we're solving for volume, what's our density? So I'm going to put 5.64 where the D is. What's the mass? What am I going to put where mass is? 89.5 goes where the mass is, and I'm solving for V, right? Now, you can solve this any way you want. I don't care, okay? Those of you with fabulous math skills, do it any way you want, all right? I saw Linda's already solved it. Okay, those of you who know how to solve, go forth and conquer. But those of you who have weaker math skills, okay, you'll find that I will only solve it one way in class. That's because over the time I have figured out that those of you with weaker math skills, really, I should stick with one way. All right, so I am only going to cross multiply in class. Get rid of the fraction. All right, most of us, if we get hung up, it's because of a fraction. We suck at fractions. I always did in school too. It was not my strong suit. Okay, I can do it if you get rid of the fraction. I can do whole numbers all day long, but fractions are my nemesis. So cross multiply and get rid of it. 5.64 times V is 5.64V. 1 times 89.5 is 89.5. Once you get rid of that fraction, there's not a soul in this room who's going to solve wrong now that we got rid of the fraction. Everybody in here will tell me to do what? Divide by what?
5.64.
See how everybody mumbled the right answer? Once the fraction's gone, everybody knows how to do it. Okay? Now, if you knew how to do it before and you had a different way, multiplying by the inverse or the reciprocal or whatever math term your math teacher used, use it. Go for it. Solve. But if you're one of the folks who you know is a weaker math student, do it that way and find the right answer. Okay? You know who you are. I'm not going to call you out or anything like that.
So the length time width time height isn't dividing.
You would only use that formula if I gave you a length, width, and height in the question. And because I didn't here, you don't need to use that. Did you get a? It's a good point. All right. When you look at your calculator, so you got 1.58. Look at the end. Do you see an E with a 1?
Oh! Yep.
Okay. So all you have to do is write your answer as 1.58 times 10 to the what? Times 10 to the first.
Yeah.
Your answer is in scientific notation, and my answer is not, which is what we're getting ready to work on. That's part of our practice. So that you get used to recognizing the differences between normal notation and scientific notation.
So those two numbers mean the same thing.
Yep. Okay, so what unit am I putting on my answer?
Milliliters.
That's right. Remember, you got to put a unit on your answer or I'm going to take points from you tomorrow.
And so the density equals, like,
Density equals?
density equals mass over volume
Yes.
to solve for volume.
Yes. That's the formula I used. This was my D, that was my M, and that was V that I solved for. Everybody okay with that? Okay. What if I gave you one like, not what I want. It's not what I want either. It's not it either. Where's the one? I guess I can do that top one. It's not what I really wanted, but the orange one. All right, what if I actually do the orange one?
Be like, what's always that?
What if that was your question on the test next week? And we should make the test probably by next Friday. I'm thinking, yeah, it might not be next Friday, it might be Monday. It should either be next Friday or the following Monday. Takes about 8 days to 9 days to do the first unit.
Yeah, Monday.
It just depends on how fast we go.
Or Tuesday. Tuesday sounds great.
Okay,
Thursday.
it just falls where it falls. Just do the orange one.
The idea.
Find me the answer.
I don't know how to start.
Think about it for a second, see if you can come up with it. Don't worry about the blue.
Okay, so exactly.
You might have to do the orange one on the test. Or something similar on the quiz tomorrow.
Are we finding the errors?
No,
Everyone's asking.
you might have to do something similar on the quiz tomorrow, yes.
That's what you said.
All right, does anybody know what to do? Go ahead, Herman.
We're finding density,
You are?
so divide the mass by the volume, so 314 divided by 27.7, and you get 11.34 grams per milliliter.
Okay. So how do you find the identity?
I thought that's what he was trying to find,
Nope.
but I don't know.
That's a you.
I need one more piece.
Wait, so we do that?
Yeah, you do that. He's correct. He's there. He's halfway to the answer.
So we do 314 divided by 27.7.
All right. When you look at this, that's a mass. That's a volume. Herman said density equals mass over volume. So he said 314 grams divided by 27.7. And you said it was 11 point what? 11.34 grams over milliliters. And I want to know the identity. I gave you something to do. Is it? Oh. That I said you could use on every quiz and every test, and the state would give it to you on the exam, and they will not say in the question, it is lead. Alright? It's lead. Find the column that says density at the bottom of the chart, and find the element that has the density of 11.3. What the heck? Now, what do we know about centimeters cubed and milliliters? They're the same. So even though this question had grams per milliliter, and your chart says grams per centimeter cubed, these two are the same. The question is not going to say, psst, check your chart for the identity. It's not. You're going to have to go in your head and say, oh yeah, there's a chart that has the elements, has density. Yes. So if you're missing a density, or you need to check a density, or let's just say I said find the mass, or find the volume, and I forgot to give you the density, where could you find the density?
On your chart.
On your chart. Okay? Now, let's talk about what you're going to practice for a little bit. So, on this question, we had some discussion about whether this volume and that volume matched, because we didn't know if that and that were the same answer, right? So we're going, I know that. We're going to practice finding our answers in normal notation and scientific notation, so you guys can go back and forth between the two. So, let's say that you're doing a chart here in just a minute. You have 25.84, what's that thick again? 25.84, I don't know, let's say decameters. And you're going to change it to, I don't know, let's do something not terribly large. Let's do centimeters. All right, how would you do that? Chart. What goes on top?
25.84 decameters.
And on the bottom? On the top? Who's bigger? How many spaces between deca and centi? King Henry died by drinking chocolate milk.
Yes.
Okay. 1, 2, 3. All right, so check my math and see if I did it right. Yes? Now, I want you to put in normal notation, which is what I did in my head. And I want you to put it in scientific notation. Okay? I want you to put it in both. I want you to get used to seeing it in both. Some of the test questions will be in normal notation. Some of the test questions will be in scientific notation.
Wait, so whatever is 10 to the third, but I thought you had the surf news or.
No, that should be the fourth.
Yeah.
Yeah, that should be the fourth. Sorry. And if I make a mistake, please tell me. Don't let me leave it up there wrong. I'm not going to get mad. Correct. Yeah. Yep, the unit goes at the end when you do scientific notation. It's a series. All right, questions? All right, let's practice. I think I have enough copies today. I made extras. All right, I'm going to tell you which ones we're going to do in a minute. Oftentimes, we do not do everything in some worksheet.
Are we done with notes?
For today, yes.
Hold on, I'll have to
That was like 2.5.
Oh, you're talking how is this metric?
Oh my god. Hate stuff like this.
All right. 1 through 7, I told you to do the odds because they're just like last time. So I don't need for you to practice many of those other than to practice putting them in fixed or normal and scientific notation. The 12 through 19 practice what we did today. Okay? 12 through 19 have the volume with the centimeters to liters. It has the cubed units, it has density, those types of things. Okay? So the 12 through 19 are the new stuff.
Can we do all of those?
Yes. But 1 through 7 are odd. Yes, all of them I want you to do like we just talked about. I want you to do them in both scientific notation
Dimes, right? Like,
and normal notation. Okay? And I will even set the answer key so you can see if you want to check your answers while I'm walking around and helping people. Yes.
So we're doing that, but not for one, right?
Huh?
We're not doing that for one, right?
Yeah.
With the diamonds.
For the dimes?
Yes.
How many dimes did I tell you have?
and then it'll be scientific notation.
How many did I say you had? What's the question say?
How many dimes are there? $25.
So $25. What goes on the bottom?
Oh, what? I didn't do that.
Oh, dog.
What are we going to? Who's bigger? How many dimes in a dollar?
10.
Calculate. This works for everything. It's not just about metrics.
So then for scientific notation, you just say the thing, then when it's not, you have the big number.
So you get 250.
Ray,
Yes.
do you have Julia Jackson?
Yes.
Could she come to guidance
Yes.
for a few minutes?
Yes. Take the vest on the back of the door, dear.
For scientific notation, we put essence equals.
Yeah. I don't care if you just write 2 answers. And then change it to scientific notation. Yes, correct.
Okay, draw.
Yeah, it's on the back side. That's just where I have the hooks hanging. I just keep it closed so the chorus doesn't sing to us loudly all day.
I know that's annoying.
I'm used to it.
We heard it in Thornhill's.
Well,
Miss Rector, she's always like, more.
I'm okay. I don't mind.
This is our homework, right?
Yes, if we don't finish it, it will be homework. If we finish it, fabulous. Then you'll just have to study for the quiz. Who has a question? Anybody? Yes.
I don't wanna do all of them and then get around with it.
Okay, so this one, go back and also get the scientific presentation. That one's correct. I was grading this wrong. Other than that, it's good. Same thing here, but good and no units. Right. Who else has a question? This one was cool.
Yeah.
You almost done?
Yeah, she's gonna graduate early and go to law school.
Cool. She's not doing McDonald's anymore.
No, she's quit law. She works at Lowe's now.
Lowe's?
Yeah.
She like that better? I would think so. Oh, no, she made it McDonald's anyway. It's driven me nuts. Those people are incompetent.
A lot of them, they go to school.
Yes, it is. They're fine. Yeah, they're fine. Do you want to be called Dylan? Okay. Yeah, I can do that. Just tell me. That's what I'm talking about. People tell me they want to be called something different 6 weeks into the course. I mean, if you train me from day one, I can learn it. It's hard, 6 weeks in to start calling you Dylan. Okay. Are y'all the dynasty or are there more of y'all?
Oh,
How many are there total?
There's 70 eggs.
I just want to meet Mom. Check her hand. 2 are going to do me in. Oh, how many weeks are in a year?
52.
52.
Good.
Let's put 52 up there. You got the charts up, right? 52. Yeah. I'm calculating.
Wait, so we can put 52 right here?
Yeah. Because you put 1 year on the bottom, right? So put 52 weeks there. No, it's 52 weeks a year. No. Same thing, yes. It is. Did you have to on your calculator? Rotate your number that you had there, which is what? What does that say? 3.78 times 100.
So 700.
Right? I say mode. Go over. Enter. Clear.
What?
You want to go back? Mode. Enter. Clear.
Yeah.
You make the calculator do all the work for you. I mean, you can do it the way you're doing it today. Make the calculator do the work.
Well, 700 is
Why is my word something?
both in there.
Oh, okay. I was just curious. Doesn't matter to me. I mean, my kids go to that. I just asked.
I'm sorry. There was.
It is, but we live out there and they started school out there and they didn't want to move, so I didn't make them.
Wait, hold on. You've been teaching way longer than they've been alive. Why should this go to school?
I don't know. We just,
Maybe
there's a school out there where we live.
Yeah.
Daycare was out there and I just didn't move them. I asked in kindergarten, they were like, no, I want to go with my friends in the neighborhood, so they just put the school with the friends in the neighborhood. Mm-hmm. Out there at West. Is that a teacher? The name sounds very familiar to me, so you should come to Lexington.
What is one Jesus Christ.
No. Annabelle. I think you know that. Oh, you're right. I love it.
When did you move here? Oh, okay, so you're new to Lansing.
Oh, dang.
You haven't been here very long.
I mean, I was at the middle school. in
Oh, so you're just recycled.
I've never.
But you know all these people, because you've been at school with them before.
I know most.
Yes, you're recycled. Yeah, you're not recycled. Oh, okay. I don't think that's an insult. I mean, you're just, moving right back.
He wants to go back.
You're going back?
Yeah.
When?
Soon, hopefully.
Sorry, my bad.
Yeah, right. Every time I saw it.
Now, I will warn you, I teach it completely backwards from Central, so you're going to be at a disadvantage. They're going to start with the atom and the periodic table and all that stuff first, and do the math in last. And I'm going to do the math in first.
Yeah.
Just be prepared if you leave in the middle of the semester. Yes. Yes. Okay. Pay attention. Stop. You get over the calculator and not do it for you with that one? It may not. Okay, then yes. Then, okay, if it won't do it, then. Sometimes if it's a really small number like that, it won't do it. So yes, you would have to do it that way. Which one?
Well, I want to put it normal.
If it's a really small number, sometimes it won't do it, which is what we were just talking about. So you're gonna have to do the decimal and move it backwards. Which one am I looking at? 13? Centi to deci would be one space.
That's one thing I mean, you change the smoothness to this.
Yeah, because deci's here, centi's here, that would just be one space. So it changes.
But you move it left.
What? Where are we going?
This.
Yeah, you got a negative next to it?
What did you say about the
No.
Yes.
Oh, yeah.
Well, special.
BS cube stuff.
That was right. That was right, that's what I just did with, what was her name? What was your name? Nakaya. Based on what I just did with Nakaya, yes, that's right. That's right, I know that one's right. That was right, so yes. Yeah.
You can
You're right there.
and that's your.
What's your name?
Oh.
You could listen.
I did. What's that? Yep, yep, that's 10. Yep, got it. Oh, you got it.
The point is your point.
What is the cube?
Yeah.
What are you doing? What is this?
No, it's just probably nice.
All right, what's your question? What am I looking at? All of them? The answer keys right on my desk.
Look at it.
Wait, where is it?
That will be right. That's not, because no cube. So you got it.
I do BS.
I usually write down the number of times.
Yeah.
Yes.
Okay,
I'm doing this.
My brain is like, if it's. I have to keep remembering that centimeters cubed equals millions. I have to keep thinking that. I just forget.
And then you took the allied health classes, and they talk about CCs. CCs are the same also.
I just have some relationship, but I
You move to the right and make
Move to there you go. Who else has a question?
I think I'm just like killing this right now, I'm not gonna lie.
So,
Let's go.
so basically, you're 45-year-old
We're solid after grade two.
No, millimeter. So it was
Yes.
49.9 millimeters.
Yes. You just write it
I
in.
can take it. Yeah, no, absolutely. But it would, you know, I would think,
Nadia, you okay? Yeah, we were sure. It's okay to check it.
depends on how long you lose. Yeah. I can show you.
You're just converting.
Make a lot of centimeters.
He's working on one of that.
of those. Just change the centimeters to millimeters.
You guys can put your calculators up.
You got solid limits right there.
We got 3 minutes. My clock's a little behind.
Math is next.
I'm ready, whatever.
Is it finished? Yeah. That's it?
Sorry.
He's saying, he's saying.
Oh, I should bring my phone up here.
Oh, here's the honey ice.
We have to do 12 through 19, right?
Yes, 12 through 19. 1 through 7 odd, 12 through 19 all.
Hey, good day.
Hey, Jake.
See y'all tomorrow.